This office has been looking pretty bland lately, and it does need some sprucing up.
This is the out-of-the-box Snowglobes hotline. For package tracking, press 1. To order a snow globe, press 2.
Oh, I like that song.
Hello, welcome to Out of the Box Snowglobes. I am Mike Brown, the manager for Out of the Box Snowglobes. With whom may I have the pleasure of speaking with today?
Oh yes, hello, I am Principal Robert Stone from Stallings Middle School.
I would like to request a globe. One designed like the school I oversee.
As a decoration to make my office more friendly and spirited.
Wonderful. May I have a short description of what you're looking to order?
The design
I need to be built is supposed to be a reflection of the school I manage. I need the hemisphere covered to have a radius of 6 inches. Inside, I would like
the shape of my school to be
a
rectangular.
rectangular prism with 2 square bases. One base touching the bottom and the other having its edge touch the upper boundary of the hemisphere. The height has to be 1/3 the length of the base.
Okay, I will get that done. Bijan! 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 Take this to our designer. What's that? Hey!
You've got mail.
Okay. Let's see what we have here. So, we need to find the volume of the inner prism to find out how much material we need to make our school. Since the base length is 3 times the height of our prism, that means we can set up the equation 3h times 3h times h, which will be equal to our volume, and we can simplify that down to 9h cubed. Let's start with a top view of our prism. Since the bottom of our base is a square, we can cut it into right triangles to find our diagonal to the center. So half of the base length would be 3h divided by 2, and since both legs are equal in length, the hypotenuse would be a leg times the square root of 2. We know that the edge of the prism touches the top of the semicircle, so the distance from the center to the edge is 6 inches, because the radius is 6 inches. Since this forms a right triangle, we can use the Pythagorean theorem to find the value of h. So now we solve for h. 6 squared is 36. 3 times the square root of 2 times h, all divided by 2, and then all squared is 9 times h squared, all divided by 2. So now we add h squared to this and set it equal to 36, and we solve for h. To do this, we will multiply both sides by 2, simplify, divide both sides by 11, simplify again, and take the square root of both sides. Now we have our height. We have to plug this into our equation and simplify, and we get 3,888 times the square root of 22, all divided by 121. This will equal 150.71352, or 150.7. Alright, this shouldn't be too long. Let's send this off to production.
Sup, bro? We got a package here for Robert Stone.
That's me.
Okay, here you go. Have a nice day.
Now that's some out-of-the-box thinking. Wonderful.